Hey everyone, I am Shafqat Farhan working as a software engineer at by Arbisoft. I'm going to talk on the topic extending OpenEdX code base beyond the core. So, have you ever encountered the challenge of needing to implement the business specific custom code changes into the OpenEdX core code base only to realize that the changes are incompatible with the broader community and shouldn't be included in the open source code base? If yes, then in this talk, I'll guide you on the extensibility and the ease of use of workarounds for the OpenEdX code base while addressing the concerns of the maintainability. We'll explore how the Django App Plugins feature of edX Django Utils repository simplifies our work by allowing us to add extension points to the core code base.
I know many of us have been into such situations where we have no other option but to implement the custom logic in the OpenEdX core code base to fulfill our to fulfill our business use cases. But we all know that there are some challenges. We face some challenges, and one of those is that we introduce some custom business logic in the upstream code base or the core code base, and which makes it difficult to maintain, and it might be incompatible for the broader community to consume. So to mitigate that challenge, today we are going to explore utilizing Django App Plugins to extend the code base, core code base, and customize it for our use case with some minimal changes. Just a note that my talk is aimed at the beginner, union level engineers or the audience. So there might be there are going to be some discussions with the theoretical aspects. So we'll be covering uh, the customization challenge, introduction to pluggable override, how does it work, and its benefits, its working, other pluggable utilities. It's easier for me to look here. Yeah. So other pluggable utilities and practical use cases and one real world example. So to start with, let's break down the challenges that arise. First and the foremost is the custom business logic implementation in the code base, right? So with this challenge, it's difficult to maintain as the upgrades become difficult to maintain, uh, as there would be merge conflicts on every named release rebase. And of course, there are going to be, we'll be introducing some technical debts. So with Django App Plugins, we can mitigate these challenges by extending the upstream code base and modifying and keeping our custom implementation separately. The edX Django Utils is the repository containing all the useful utilities, including the Django App plugin. So we can use this across the OpenEdX Django projects to achieve the pluggability. Now, let's talk about the pluggable utility, pluggable overrides utility. So it is one of the Django App plugin utilities. It allows you to dynamically override any existing function or method in the code base, for example, the edX platform. And so what it does is it keeps the customization separate from the code base, and it enables you to read the overridden configurations from the Django settings itself. This overridden function enable you to inject multiple custom implementations. So we can use the chaining here of the custom solutions. And all of this without altering the upstream or the main original function or the code base. And in my opinion, This is very useful for all those large open source projects like edX platform, where you don't want to add the business logic directly by modifying the original code base. Okay, so how does it work? So first, we need to, as a prerequisite, we need to install edX Django utils in your core Django project. And the next thing is that you need to write an override function in your pluggable app and install that plugin app in your core project's requirement. The third step is the final one. Then you need to register an override for the original function in your core code base using the decorator, because the pluggable override is can be consumed using the decorator function. And with all of this, once the yeah, with all of this, once you have registered it successfully, whenever you call your original function, it will execute its custom implementation. Yeah, so here's an example code snippet and the flowchart to explain you visually. As you can see, this original function is overridden using the pluggable override decorator. And so in this example, any call to the original function will use its custom implementation instead. And as you can see in the diagram, once the system identifies that there is an override registered, it executes its custom implementation. One thing I forgot to mention in the previous slide is that it doesn't only override the existing implementation, but it allows you to wrap your custom implementation around the original one as a pre or the post implementation. So let's talk about the benefits of pluggable override. Number one being the separation of concerns. As you know, it keeps the custom business logic isolated from the core code base. And number two is the maintainability. So it makes the upgrades, as I've explained previously, it makes the upgrades easier to manage, as there would be no merge conflicts with the upstream code base, and there won't be any technical debts introduced, as we will avoid forking the repository. And yeah, again, as the customizations are isolated, we can document it in the one place. So it's all isolated and documented separately. And one of the most usable benefit of this is the extensibility. So as we know that we can easily add or remove features for different deployments, because it doesn't require a deployment to pull in or pull out any of the features or any of the chain of the custom implementation you have implemented. So with this, obviously, which means that it supports the A/B experimentation and the feature toggle capabilities that we have in Django. And yeah, as I mentioned, that it supports the chaining of multiple overrides. We can write multiple custom implementations with the overridden logic. And yeah, the reusability is one of the other benefits, as we can easily package this and reuse it in across multiple projects or other applications, Django applications. So edX Django Utils library offers several other plugins, including plugin settings, plugin apps, plugin context, and plugin signals, to name a few. So I can go briefly one by one on these to just give you an idea how other utilities work. And then it will give you more context, because my talk is initially focused on just one, which is the pluggable override. to give you an idea on how this works, and others work similarly in its way, but it touches at the different aspects of the application, like the signals and the settings. We can override these things with the pluggability. So first, the plugin settings, which allows you to define and manage the plugin specific settings in your core project. So which means that it supports the dynamic configuration of the project. And with the plugin apps, it manages the discovery. You have the leverage to manage the discovery and registration of the plugin apps in your core projects, Django's installed apps settings, which means you are enabled to add or remove the modular pluggable features. About the plugin context, it's on the mostly on the view side and the template side that you can easily, it allows you and enables you to extend the view context with some additional data. You can easily enhance your views by adding, by passing the business specific data for your own needs via the pluggability. Yeah. And as the name suggests, the plugin signals enables you to manage the Django signals for the plugins. It connects the plugin signals uh, for your plugin app. Plugin app signal receivers are configured and connected with your core Django project at the runtime. I'm sorry if the theory is boring, but it has to be covered. As I mentioned earlier, the intended target audience are the beginner level or junior level engineers, so the theoretical part has to be covered. Okay, now here are some practical use cases of pluggable override that I've extracted from the OpenEdX different applications, but these are just to name a few. There could be other as well, practical use cases. But the ones that I have used personally for the clients and I have extracted are the common ones which I've listed here. First one is that override, we can use it to override any common utility in edX platform. I'll demo one of the utilities in the upcoming slides. And the next one is that we can extend it for, we can use it to extend it for our e-commerce functionality. And this is also related to edX depreciated e-commerce part or the e-commerce utilities we have in the edX platform. For example, the refund functionality or the upgrade course, call to actions, and any touch points that are related to the e-commerce journey. So we can easily customize it. And this this will help those who have integrated the custom e-commerce solutions in their OpenEdX projects. Yeah, the custom Django views, we can use it to customize, as I have explained previously, the Django views by extending its view context and providing some additional data or template data. And one of the other practical use cases I figured out was the grading and the certificate logic, as it can be used to implement custom grading policies or the certificate generation logic. And for the user management, we can definitely use it for our custom registration, authentication, and whatever there is in edX. Yeah, the profile update logic for our custom workflows for our own project needs, based on our own project needs. And yeah, and finally, we can seamlessly integrate any external system by overriding their relevant functions, because it's just decorator based. You can override anything that is in the core and use it with your custom implementation. In short, we can leverage the use of pluggable override for any of our business use case by just extending it, and the original function remains intact. Okay, so yeah. Practical example, yeah. So let's explore this real world example. It is related to the e-commerce, which I've chosen on purpose. I'll explain later. So the first thing that you need to do is to identify a utility to override in your core project. So I've picked this get absolute URL utility. What it does is it returns the e-commerce system's URL for the specific use case. Second thing is that we need to implement a custom solution, custom logic in our pluggable application and install it. I have explained previously. So in this screenshot, as you can see, this is an overridden implementation, and what it does is it returns an alternative e-commerce system's URL. So it's a simple example, but I'll just to give you a visual representation of how it is different, how the pluggable overriding works. So out of the 3 steps, the third step is that you need to register an override on the original function. So this get absolute URL is overridden using the pluggable override decorator, and it is registered, as you can see in the second screenshot, to a custom module, which is installed as a plugin in the core project settings. So this example, I have prepared a demo for it. I'm going to play it for you to visually explain how it works. So there, I've split the demo in 2 parts. This upgrade button, the call to action, clicks, the on-click function is the get absolute URL function that I've overridden. And the first part of the demo is to show you the original implementation without the overridden logic. And the next part is how it works with the overridden logic. So this is its original implementation. As you can see, there is this decorator written over here, but it's not yet registered in the Django settings, because for the sake of the demo, I have commented it for the first part to show you the original execution logic. So this is how you register a module, by passing, adding a flag and passing it in the custom module path. So since I've commented it for the first part of the demo, this shows that if we click on that, it will execute the original implementation, right? Now, by registering the module, which means that we have registered its custom implementation, and if the system identifies it and finds it, and when there is another click to that call to action, so this is the custom implementation I've shown you in the previous screenshot, that it points to the alternative e-commerce systems URL. So now clicking on this call to action will execute its custom implementation, just to show you a demo that how we can override it, and not just fully replace it, but we can wrap it around the original functions implementation for our own needs. Okay, so yeah, so as we wrap up, here are some key takeaways. The pluggable override and the related plugin utilities, they enable you to customize the Open edX applications safely and cleanly. Um, yeah, so we can achieve the clean code aspect as well. And these utilities, they can be used to extend any service with the code that is not core to the code. And it supports the chaining of the custom implementations. As explained previously, we can implement multiple custom. We can override the function with multiple custom implementations and configure it via the settings without the deployment. And of course, it's flexible enough with the original implementation. Like we can totally replace it, or we can wrap it around the pre or post of processing of the original function. So if you would like to learn more about these utilities, I have included some helpful references to the code repositories and their documentation. Do check them out. I'll try to add it to the portal after this talk. And yeah, thank you for your interest. As we have wrapped up earlier than expected, so all I want to emphasize is that my goal of this talk was to and is to encourage everyone, and we should make our goal to make edX platform extendable via the pluggability, and which is simpler, easier, and easily maintainable, and reduces the friction with the upstream code changes. So if you have any questions, please do ask.
Thank you. What is the chaining overrides? As an example, could you provide something?
What is Django overrides?
Chaining
Overrides, yeah. So I'll show you. There was one screenshot where we, sorry. This second screenshot where I've shown you that we have used this Django settings flag and added a custom module path, right? So how we can chain it. It also takes the value as a list. So we can share multiple module paths, and the order is in the sequence of execution we write it. So if it is registered with any of the module paths that gets resolved, all those modules will get executed one by one.
Yeah, thank you. Get it.
Hi, I have, I don't know, 2 questions, 2 comments, whatever. So the first one is that how does this differ from OpenEdX hooks framework? Because we have used it to customize views a couple of years back to change I think the rendering of a page to inject some, to wrap a final rendered X block or I don't remember exactly, but the final rendered HTML by wrapping more HTML around it. What we did was we introduced a hook and then passed in like OpenEdX filters. Used OpenEdX filters to wrap it. That's one. And the second
for the front end part.
Yeah,
for
the front end.
Part,
yeah. I think OpenEdX hook is something like X block finished rendering or something like that. So you will get the context with the HTML in it, and then your filter can do whatever it wants with the HTML. It can replace the HTML, it can augment the HTML, however you have it. So that's one thing that we did. And the second question or the comment is about this works really well in situations where we are using plain Django views, but with the move to MFE and the API-driven, API-driven development that we do these days, we really need to have the support in both backend and also have some changes to be included in the MFE for the full functionality to be wrapped up together tightly. So yeah, I don't know whether it's a question, but it's a comment on.
I can try to answer that. Yeah. First part about the hooks. I might be wrong, but I think it is a thing from the past, and we have evolved. And this edX Django utils is a single, resource hub, you can say, of utilities, all the common utilities. And this specifically that I am presenting is the part of Django plugin apps, and in which for the front end, plugin context can be used for that purpose that you were mentioning. So it houses all the common utilities that can be consumed by any Django project, not just the OpenEdX. And for the second part, I think in the MFE infrastructure where we have to communicate with the platform via the API calls, eventually the source of data is the backend servers, right? And this works with Django. So whatever the infrastructure is, even the plain Django app or with the MFEs, there has to be a function or a view or anything that we are calling, and we can override that single source to achieve that goal.
Actually, I was involved in the implementation of the hooks framework, and we were doing some discovery and research. These already existed, and actually filters, they behave kind of similarly. But with pluggable override, you need to, if I want to change, I don't know, the view that renders X blocks, and I want to change the middle of the view, or when I want to change just the start, then I had to, and correct me if I'm wrong because I haven't used pluggable override, and when I reviewed this was a long time ago, you have to copy the entire code and then modify it, because it is a wrapper. I don't know. That's how I think it works. And filters, you have like entry points at the beginning of the view and or at the beginning of any process, but I do think they share a few. They have common things, and you can use some of it to implement and have similar outputs. So I was sitting here and I was thinking how we can unify all of this, because I don't think it will be like, it is a good idea to have multiple things that maybe they don't work the same, but you can achieve similar goals with it. And I do think it has impact in maintainability. But yeah, whatever. That was just my question, my answer regarding the Xbox thing. So I need, for me, I'm a maintainer of the hooks framework. So for me, I have like an action item of thinking how we can unify this. And my question was related to what he said. Like, if I want to change, maybe, I don't know, I remember, and this is not correct this day because we have the MFE, but when Learner Dashboard was a Django just template, a plain Django template, I wanted to change how the, I don't know, how the user view the courses in their dashboard. So if I wanted to change that, how can I actually reduce the maintainability efforts if when I'm adding this, when I'm implementing my override, I need to copy. Do I need to copy the entire view?
Your both
or
questions have one answer.
Okay.
And that is that there is no code duplication. In the overridden function, as it's a decorator, the original implementation is passed as.
So you execute it like first,
or we can execute. We have explained that we can wrap it around our custom logic. The original function.
Okay, it's not like you replace it.
It's
no.
not like
okay,
replacement.
great.
You can,
I didn't
if
know.
you have to extend, you can even call the original function and execute your custom implementation either before or after that.
Or
project.
after.
So there's no duplication of the original thing.
Yeah, and that brings me to like, we need to find a way, and I don't know who I can talk to, if someone here is maintainer of edX Django utils, or if someone was actually involved in implementing pluggable override, because actually I think filters and these kind of overwraps. But yeah, another question I have, and this is a problem it's just for plugin developers per se, and it's not a problem that we might solve soon, But when we're developing and we need to interact with the platform, and we want to implement things that are really flexible and actually impact the user, the student, the author, or whatever, we need to import things from edX platform. And I don't know, I've struggled with that, and that breaks things. Like, it is easier to migrate from a version to another using plugins instead of forking, but you are still importing course overview models. You still importing module stuff that it's currently around. So for simple views, when you're adding and modifying, and that also happens with filters, like, oh yeah, this is great, like, or when you are injecting something to an object that you actually have access to, that's easy. But when you want to do creative things, that's really hard because you're still dependent in edX platform. That's a big thing.
Obviously, there are some caveats of this approach and of any approach. I wanted to ask later in the question answers, but you have just said it, so I'll just explain. There's one downside of this approach and that is if the original implementation function gets depreciated, or its signature changes, or its argument changes, so it will break things for the overridden function. So we'll have to, it's not just it's written one time and it's overridden. There has to be some, it should be maintained and documented well, so we can backtrack that and update our custom logic.
Yeah, no, we need to find a middle way. We need to find something. We need to find a solution, and that's because it is hard, and people do it. Like, we suggest against importing from an X platform, but sometimes there is no other way.
Yeah.
Thank you.
You know why I've chosen this example? I was working for one of the clients who have their own custom e-commerce solution, but they wanted to have the proper e-commerce integration with edX, like we used to have with the Django Oscar, the legacy depreciated e-commerce. So we come up with a way. We found this pluggable utility, pluggable override, and contributed to the edX platform to just add it as a decorator, and we released it in one of the named releases, and we extensively use it just by overriding the original logic, so that the core OpenEdX business rules are also maintained. For example, there's one that you can, there's a method upon unenrollment, you can trigger the refund, right? So we integrated that with our custom solution by just overriding that refund function. So this is why I chose this example, because it is one of the use cases that I think is under discussion since a long ago in the e-commerce solution, and we fixed it for us this way and also contributed via the pluggable override.
So you contributed
Not the library, but its use case for the e-commerce in the platform. Yeah.
Okay, great. Thank you.
So you're talking about the override, and you said that you're choosing to limit your talk about that. So is there an opportunity to like plug in new functions that don't exist for custom
New
logic?
utilities, you mean to say?
Yeah.
So
So all you're talking about overriding a specific function that exists.
Exactly, yeah. These plugins only work in the existing environment.
Okay.
The overridden pluggability and the other plugin utilities we have in the edX Django utils repository.
Okay. So it needs to be something that already there's a function for it that then you can.
The thing is, we are extending whatever is there for our own custom implementation.
Okay.
Was this not interesting to any of you? All right. If there are no other questions, we can end. Thank you.